Hello everyone, I'm Tan. Welcome back to my project, which is exploring vulnerability in IoT devices. In the second video, I'm going to talk about the introduction, the general of encryption schema, and the vulnerability of the access point. In computer networking, a wireless access point, or more generally, just access point, is a networking hardware device that allows other Wi-Fi devices to connect to a wide network. The AP usually connects to a router as a standalone device, but it can also be an integral component of the router itself. Wireless access has special security considerations. Many wide networks place the security on physical access control, which means charging on the user on the local network. But if wireless access points are connected to the network, anybody in range of the AP can attack your network. The most common solution is wireless traffic encryption, which makes access points to come with built-in encryption. The first generation encryption schema, EWEP, it is easy to crack. The second and the third generation schema, which are WPA and WPA version 2, are considered secure if a strong enough password or password is used. Some AP support hotspot-style authentication using radius or other authentication servers. WEP uses an algorithm called RC4, where each packet is encrypted at the AP and is then decrypted at the client. It ensures that each packet has a unique keystream by using a random 24-bit initializing factor. This IV is contained in the packet as plain text. The short IV means in a busy network, we can collect more than 2 packets with the same IV. Then we can determine the keystream and the WEP key by using statistical attacks. The more IVs that we can collect, the more likely for us to crack the key. What if the AP were idle or had no client associated with it? In this case, we have to inject the packet into the traffic in order to force the router to create a new packet with new IVs. There are 3 methods to increase the number of the IVs privately in APs, which are ARP request reply, current job, and fragmentation attack. In ARP request reply, after successfully associating with the target AP, we will wait for an ARP packet. We will then capture this packet and inject into the traffic. This will force the AP to generate a new ARP packet with a new IV. We capture this new packet and inject into traffic again. This process will repeat it until the number of IV captured is sufficient enough to crack the key. In current job method, we will capture an ARP packet and return to get its keystream and use it to force a new packet. Then we can inject this new forced packet into traffic to generate new IVs. The goal of fragmentation attack is to obtain 1 and 500 bytes of the pseudo-random generation algorithm. This can be used to force a new packet, which can be injected into traffic to generate new IVs. WPA was designed to address the issue in WEP and provide better encryption. In WPA, each packet is encrypted with a unique temporary key. This means the number of data packets that we collect is equivalent. WPA and WPA version 2 are similar. The only difference is that WPA version 2 uses an algorithm called CCMP. To exploit the vulnerability of the WPA and WPA version 2, we can use 2 methods, which are Wi-Fi rotated setup and a workless attack. Wi-Fi rotated setup is a feature that allows users to enable network easily by using a WPS button or only by clicking on WPS functionality. Authentication is done using an 8-digit long PIN. This means that there is a relatively small number of PIN combinations and using brute force We can get a ping in less than 10 hours. A tool called River can then recover the WPA and WPA version 2 key from the ping. In WPA version 2, the package is not useful as they do not contain any information that can be used to crack the key. The only package that contains information to help us crack the password is the handshake package. Every time a client connects to the AP, a four-way handshake occurs between the client and the AP. By capturing the handshake, we can launch a worthless attack against the handshake to determine the key. To crack the key in AP with WPS disabled, we need two things: capture the handshake packet and a word list. A word list is a list of passwords to get the key of the encryption. It can be downloaded from the internet or created by an attacker. In the next video, I'm going to talking about demonstrating and exploiting the vulnerability of IP camera. Here's my reference that I used for the presentation. Thank you for your listening. See you for the next video.